Okay, good morning, everybody, and welcome here to our special lecture from AI Sweden and from the AI Labs. It's my great pleasure today to introduce to you Dr. Mary Bell from Dakota State University. And also with us here in the audience in Göteborg are a number of students from Dakota State University who are here with a number of Swedish graduate students in our summer program in cybersecurity and AI. So we have a good representation from South Dakota today, and it's very exciting to hear what Mary has to tell us, and I'm going to pass it on to her right away. And let's enjoy the talk, and please ask questions towards the end of the lecture.
Great. Thank you so much, Mats. I really appreciate it. Thank you so much for being here. Good morning. Being part of the establishing on the consortium of securing AI is really a great benefit and opportunity, and I'm so thankful to be part of that. So thank you, Mats, and thank you for inviting me in. Last September, I was here, I was in Stockholm in Sweden, and I gave an introductory presentation on the cybersecurity of critical infrastructure. I'll do a little bit of review on a couple of concepts from that presentation, and then I'm going to build on that more and really talk about the use of AI in cybersecurity of critical infrastructure, focusing specifically on the electric grid. I'm going to start just a little bit about who I am, because I have a very non-traditional background for somebody who is in my role. This is the agenda of what I'm going to cover today. I won't read anything to you. You can see it. We will go through this. I generated this photo here on the left using DALL-E. I specifically asked it to make it as a woman in her mid-50s. How do you think it did? No comment necessary. Apparently in DALL-E, if you're in your 50s and you don't have short gray hair, then you're not in your mid-50s. But this is an example, and I tried many iterations. One of the things we talk about a lot is the prompt engineering, and I work so much to practice on prompting, and I'll just do things just for fun and practice for hours sometimes just to try to generate different types of images or concepts just for practice. And I laugh because after quite some time, this is what I ended up with. So this is what you're getting. Not that it's representative of me. This word cloud here on your left then is, I took the basic concepts from my CV just to give you an idea of a little bit of who I am. I am on my third career. My first career was as an active duty aviator in the US Army. My second career was as a professor at the National Defense University in Virginia. And then now I'm in my third career, in my current role as Beacom Dean of Computer and Cyber Sciences. When you think about all the kind of maybe random things that I've done over my life and how those things come together to shape who I am today, and I'm just going to do a quick review of what some of those things are. It'll be relatively quick, and I'm going to do it through pictures just to give you an idea. So here first, I was a UH-60 Black Hawk helicopter pilot. The picture here on the left is one in California. The one on right is one in South Korea. I also had duty stations in Texas, Hawaii. I was deployed to Haiti as part of Operation Uphold Democracy, which I think there was a little bit more stability in Haiti, and now it's quite a disaster again. That's a topic that we could talk about another time. I worked in Texas and Louisiana and just all over the United States, in addition to other places overseas. And then I did have a tour teaching at the Air Force Academy. It was my one non-operational tour whenever I was flying. I've flown many different platforms. Here on the top left, you see a C-12. I flew that for a year. I flew in a couple of missions in the backseat of an F-15. That's me with my thumbs up saying, hello, here I am. A quick little story is the name here. They'll put the pilots' names of that plane on the platform. It says Captain John de Leon, and he, 12 years later, was a student of mine. And I randomly was going through pictures. I never would have noticed the name. And then one day I was going through pictures while he was a student. I'm like, you will not believe this, but I flew in your plane when I was in Okinawa. That was in Okinawa. This picture here on the bottom right is in Haiti, and that's President and Mrs. Carter. I've flown a lot of different VIPs from State Department to Department of Defense, and had this opportunity with President and Mrs. Carter. And then this platform here on the bottom left is called the de Havilland-7, or the Airborne Reconnaissance Low. And that plane is something that it's a reconnaissance plane. So this is where we get into some of the things that connect me to the role that I do today. It's Airborne Reconnaissance Low, or ARL is this platform. And I spent years doing counter-drug missions in Colombia, in South America. So this is an example. I was the task force commander. As task force commander for that mission, I think I did that for 3 years. I had soldiers in many different locations, from the National Security Agency site in Texas, Arizona, Florida, Colombia, in the embassy, multiple places on different islands in the Caribbean. So that was a mission that we did for a very long time. And I really focused on signals intelligence. Whenever you think about the terrain in Colombia, it's very thick vegetation. So imagery isn't such a good use. So we would really use the signals intelligence and listen to the radios, and that's how we would gather our intelligence while on that mission. I was in Iraq for 2007 for what we call the surge during Operation Iraqi Freedom. I worked specifically for the Special Operations Command, and for this mission, it was full imagery. And whenever we do the imagery mission, the agency that we team up with is the National Geospatial Intelligence Agency, or NGA. So I worked with them, and then I flew this mission. It was a direct action mission, meaning I would fly, I'd have a team member from the Special Operations Command directing action on the ground. We could be following a truck, or we could be taking out a target. Whatever that operation was, they would direct that action from the back of the plane. My last flight active mission that I did was as a treaty negotiator for the State Department on what's called the Open Skies Treaty. It is now defunct because of the Russian invasion into Ukraine. Primarily for those 3 years, we overflew Russia, but we worked together as a treaty mission to do so. So the picture here on the left, I worked many times with the Swedes. I had been to Sweden many times before I was in this role. The man on the left is the Russian counterpart. The man on the right is the Swedish Air Force counterpart. And then here's a small team of mine in front of a Romanian AN-36, flew on many different platforms. Usually we flew on what's called the OC-135, a big US plane. My last role was as the National Defense University. I did that first as active duty, and then as a professor, working my way up through the educational academic ranks at the National Defense University. These are my students. They would be lieutenant colonels and colonels, and I would teach them how to do the strategic planning at the highest levels. How do you think strategically? How do you create war plans? How do you work in that Department of Defense to create stability from a US perspective? I quickly wanted to talk about this one special mission I did with NATO. This was last August. We met with members of the National Defense University of Ukraine, NDUU, and they came to Poland, and we had about 50 people working together to do this mission where we talked about lessons learned from the Russian invasion of Ukraine. And so we captured those to help NATO better understand how to defeat certain types of adversarial actions. Where this is going to come into play because I'm going to do a little bit of a case study on an attack onto the electrical grid in Ukraine in 2015. So now getting into the meat of the presentation, as industry leaders and students and people going into industry or defense, working here with AI Sweden, you understand the critical importance of securing our most vital infrastructure and thinking about, as a digital world, an increasingly digital world, what does that look like? Whenever you think about the electric grid, right, it's really the backbone of everything we do. When you think about the different levers of power, so you have economic power. Economic power, when you think about finances, how can you do financial transactions without electricity, right? Those systems cease to operate well. You think about health, and you think about the healthcare systems and how if you don't have reliable electricity, what that does in those systems. We will often say that the demarcation between the most developed nations and those that are continuing to develop is the reliability of electricity. If you think about it in those terms, how critical electricity is to everything that we do in our modern world. It's what keeps us connected. What does that mean? And so what does it mean to secure it? It's super important. Whenever you think about AI and cybersecurity and what that looks like, we're going to talk about that more today. Just a little bit of a review now, if you happen to see my presentation in September. Critical infrastructure. I did a lot of research to see if Europe or Sweden specifically defines critical infrastructure differently than we do in the United States. Everything that I found kept coming back to the US definition, but maybe it's the world's definition and the US just says, this is the US definition. I'm not sure which, but these are basically the 16 sectors of critical infrastructure. I know it's not super easy to see, but you get the idea of what those are. And then here squarely down in the bottom is energy. And we're going to talk about then more specifically energy as a critical infrastructure. IT and OT. People are very familiar with IT, information technology. People tend to be less familiar with OT, operational technology. When you think about operational technology, you're talking about those physical systems that are part of that infrastructure. So if it's a water system, there could be dams, there could be pipelines. If you think about natural gas pipelines, when you think about electricity, it could be that power plant, but then it can be the power lines that connect the people to that power plant to provide that electricity across the grid. Those are all pieces of this operational technology. Now, you can see in the middle of, if the picture didn't come up, I just don't think you can see it. There is supposed to be a Venn diagram here. The circles are missing, but if you can imagine a circle where the Venn is this part in the middle, that's the part where what happens a lot with the IT and OT is they don't overlap. The people who know IT don't know OT, and the people who know OT don't know IT. That's a problem. And it's something at Dakota State we're actually working to increase this knowledge, because we think the person, the graduate who's an expert on OT who understands IT, and the expert on IT who understands OT is an underserved population. And we think it's super critical to start bringing those together more. Talking a little bit more about OT, operational technology. When you think about it, this is what it looks like. So within it, you have the ICS, which are the industrial control systems. Again, I mentioned a little bit about what those are already. Within that, you have DCS, the distributed control system. Generally speaking, the DCS are, for the most part, they're contained. So if I'm sitting at the power plant working and I maybe can see that lever needs to be changed or this needs to happen, I'm there on station. Generally, it's not always 100% that way. But think of DCS as relatively protected because it's connected. It's right there. Then you have, we already talked about the ICS then is the industrial control system. We talked about that. And then you have the SCADA, which is the supervisory control and data acquisition. This is where you start to get really vulnerable, because those SCADA systems are systems where I'm remote. I'm not at the location. I'm at some decentralized location over there where everything comes to me through IT, right? Vulnerability, right? Because I'm not sitting at the station. Even if I'm sitting there, there's a vulnerability, but I'm less vulnerable. So at this control node, if you will, the SCADA site, that's where you have the real possibility of having these cybersecurity threats. I'm not going to talk through these very much. Again, this is a little bit of a review from last time. So I know that you all weren't there necessarily, but you can just see through some of the threats. Here's legacy software, default configurations. These are some of the things when you think about SCADA systems being remote, it's just like it would be in any IT system. What are some of those? But the real threat then is how do we interject ourselves as an attacker, as an adversary through the IT and work our way into the OT? It's through the SCADA systems. That's the most likely way for that to happen. Can I go and plant a bomb or something at a site? I can, but that doesn't have the same effect as me working my way in through the IT. Okay, now we're going to really start getting into the new material that I'm going to cover for this one. And that's that AI's role in cybersecurity. So as you think through, I'm not going to talk through all of these in a ton of detail. It's a lot. I tried, I think 9 is too many. There's studies that say remembering 9 things, it's too much for the human brain. Most people are good with 7 plus or minus 2. So we're getting in the ballpark of that. When I looked at these 9, I tried to kind of consolidate, but these are the ones that I really ended up sticking with. So threat detection and analysis. Through AI, when you think about anomaly detection, If you train the AI, and these are just really basic cybersecurity concepts in general, and then thinking about specifically how to apply them in the electrical grid, we're going to work on that. But these are just cybersecurity concepts in general. AI algorithms can be used to identify unusual patterns in network traffic, system behavior, and other activities that might indicate some type of adversarial behavior. Again, behavioral analysis, the AI, if it knows what it should look like, it can just pick those up much faster. Automated incident response. We have companies who are constantly talking to us at Dakota State saying, hey, can we hire students to come in and teach them how to help us with incident response? Because there are these surges that happen, and it's usually when, Friday night at like 7 o'clock or something like that. And they're really looking to increase the amount of people power to help respond to those incidents, and you need to have it fast. Well, the better we train our AI to do that incident response, because it takes us longer as humans to recognize it, well, the AI can do it faster. So that's one area that could be a huge help. Predictive analytics, when you think about threat intelligence and you think about how the AI can know better, it can scan just so much data and go through and figure out what do threat vectors look like, what are new threat approaches, what are some of those attack systems that they're using. The AI, if it's well done, can help detect that faster. Vulnerability management, you have that continuous monitoring. When you think about that, then the patches. So if there are patches that come out, the AI could detect those faster. It could generate patches, perhaps. There's so many things that could happen there in that area. Encryption and authentication. One of the things that we are starting to offer this fall at Dakota State is a quantum certificate on cybersecurity, because as we think about encryption and we think about a post-quantum encryption world and what that looks like, so we're always trying to think ahead, and encryption is a big part of this, because that, when you think about the layers of security through encryption, that's significant. Phishing and social engineering defenses. In the neighborhood, depending on what study you read, 85% of all cyber attacks are the result of a spear phishing success story. If you're a bad guy, right? Spear phishing success. If I'm a good guy, that's a bad thing to happen. And whenever we talk about this case study I'm going to talk about, that was their attack vector into that electric grid was through spear phishing. So when you think about AI and how you can prevent that, email filtering, if there's unmonitored accounts, the AI can pick that up faster. Maybe unmonitored doesn't mean that somebody left and then we didn't activate their account. Maybe somebody had a medical emergency and their account is unmonitored, as an example. Well, the AI could pick that up because it would know faster if that system wasn't being used, and it might be more vulnerable. And then network security, intrusion detection systems. I'm going to talk in a couple minutes about a program called Mosaics, and it's a program designed out of Johns Hopkins University Applied Physics Lab, and they've created this program, and that's a detection system. And things like that, as we think about that, AI can really be used to enhance those systems. Deception technology, honeypots, decoys, right? So we can create these systems to lure maybe bad guys in, and through those honeypots or these detection systems, we can learn more about how they operate, how they intrude into the systems. And using AI to enhance that, it can be so much faster than what we can do as humans as we do that. And the last one I'm going to talk about here is supply chain security. And whenever you think about, again, my examples are going to mostly be from the US because that's my experience. Like, so we have these big companies, Northrop Grumman, and they are very cyber secure. They have good systems, but then they have supply chains that are these small organizations. Maybe they're very rural. At Dakota State, at their request, a lot of these small organizations will ask us, hey, can you tell us where we're vulnerable? So an example is we got into our students, really just amazing students, got into a bank system through a printer that hadn't been protected properly. If you remember, there was a major attack on a cyber attack on a hotel in Las Vegas, and they got into that hotel through a fish tank that was connected to the system. And those are the types of things when you think about perhaps supply chain and what does it mean down the line in this rural area where they don't think about cybersecurity in the same way. A lot of people in South Dakota in government have like Yahoo accounts and AOL accounts because that's what they've always had. And so we're working on ways to think about supply chain and what it means at every layer. Traditional grid versus the smart grid. When you think about the traditional grid, there's multiple names for this. You can hear conventional, you can hear legacy. So if you hear traditional, legacy, conventional, all of those, they all are synonymous with this same concept here. It's a one-way system. So think about a central power plant that distributes power throughout that grid. Pretty simple, pretty basic. And then when you think about a smart grid, it can send power out, but it can also receive power. So if I'm a wind turbine farm and I'm generating power, which generally the wind blows mostly at night, and I'm distributing that power, I can distribute it back out through the system. Or if I'm just a single home with solar panels on top during the day, maybe I can provide energy back into the system. Smart grids have the ability to do that. Traditional or legacy grids have less of that possibility. You can look more on some of the areas here. I specifically wanted to talk just a little bit about an example in Sweden, which most of the grid here is a traditional grid, right? As it is in most places. So very advanced nation, but we have these legacy or traditional grids that are really, when it comes down to it, very vulnerable to cyber attack. You are creating at the Stockholm Royal Seaport a smart grid. And by 2030, it's expected to be, we'll see, how the progress goes, but it's being built, it's on its way. And once that's done, it's going to have a lot of these additional abilities and then enhanced security, because cybersecurity is built in at the very beginning. It's not an afterthought. We didn't build it back in the 1950s and then add computers in the 1980s or 90s and not think about the fact that it's possible somebody's going to want to hack into that and do bad guy things. Just a picture here of what I just described. So on the left, this is the traditional or conventional grid. You can see it's one-way system, power flows out. The nodes are not connected in any special way. But then you have the smart system where it's two-way power flow. It's smart. It can think about how to use power. Another thing that we've done at Dakota State is we've asked students in one of our labs to look at ways, like the electric company can say, hey, if it's a super hot day and you're not home and you're at work that day, would you allow us to shut off maybe some of the systems in your home to conserve energy, to provide that energy in other places? And a lot of people will sign up and say, yes, I will do that. It's elective, you can do that. And then through this system, it will send a signal from the power plant to the home to say, turn that system off. One time. The students have developed a way to actually check, did it stay off? Check it every 3 seconds, because what could happen is it could turn it off. And if I'm home and I'm like, well, that's annoying, and I turn it back on. But the electric company thinks it has conserved power by turning, and think about this times thousands of homes, right? It has a huge effect. Well, as you develop and improve these systems, it can be two-way signals, and it can continually check to see if that is off. Now, if I'm home because whatever I was traveling overseas and I get home in the middle of the day or whatever it may be, that doesn't mean I don't have access to it. But then the SCADA operator knows that I've turned it back on. So then it can adjust accordingly. Maybe you won't have those rolling blackouts as you hear. Talking about 2015 and the attack on the electric grid in Ukraine. The original attack vector was a spear phishing email, as I had mentioned. We know for a fact that this malware, Black Energy 3, was introduced into this system. There's 3 electrical systems grids within 3 regional grids within Ukraine where this was introduced. The attackers were in the system for months, gaining intelligence for months. Nobody knew they were there. Didn't know to look for it, didn't know they were there. Through that, they gathered all this intelligence and learned ways to figure out how to actually shut down these grids. So there was a concerted, concentrated effect in 3 different regional systems where they jumped through this malware from the IT to the OT, and they took over the SCADA system. It wasn't too long. It was only a few hours. It was about 225,000 people. But when you think about that from a financial or the effect, a couple of hours is a lot. It could be the matter of life or death, literally. Think about what those effects are. Think about if part of Gothenburg lost power for 3 hours, huge sections of it. What would that mean from just people's trust in the system, right? People's trust means a lot. From a financial perspective, from a health perspective, think about all the ramifications. Maybe the water isn't flowing because you don't have the electricity to run those systems. There's so many effects that could happen. So as you think about what it means to have the cybersecurity and how to use AI to enhance that, it's very important. Here's some of measures that we can use to protect the electric grid. I've talked through a few of these, and I think some of them start to jump out as I talk, yeah, that makes so much sense. Ways to segment the IT and OT, so that if there's ways to protect those grids from somebody jumping in through IT to affect the OT, how do I segment to help protect that from happening? Or I segment different parts of the grid. So the Colonial Pipeline attack in the United States affected like 1,500 miles of pipeline. And things like that, when you think about how do you segment that and protect that, these are ways that we can think to make it better. Flight training and awareness, right? I said 85% of all attacks are through spear phishing emails. And so if you think about how do you teach people to be smarter about that, in this community that I'm talking to here, I think it's something you're very aware of. At Dakota State University, at least for the employees, I don't know if we did this for the students, but they send us these spear phishing emails to test us, to see if we will click on the link in the right way. And sometimes we're in a hurry, especially, you're just like, yeah, that's, you don't think about it. You're like, that's legit. You click on it and then you did this wrong. And then if they really are annoyed with you, they make you go through remedial training before you can have access to the network again. That shuts me down for like maybe an hour. It's super annoying, but it really, it happened to me within a month of starting at Dakota State. And I'm like, oh, that's really embarrassing. I don't want that to happen again. So I become more aware. Did that email from Amazon Web Services come from Amazon Web Services, or did it just look like it came from Amazon Web Services? It does make me stop and think. And it's just simple things like that usually is all it takes to prevent a lot of these things from happening. Multi-factor authentication, MFA, super important, right? You could use biosystems. So I could use the touch, I could use fingerprints. If I'm in a SCADA system, it could be eyes. When you think about certain things, just it's such an important layer of security. And just something like that using MFA or a biometric system is a significant improvement on the cybersecurity of that network. Zero trust architecture, ZTA, we talk about that a lot at Dakota State, and the importance of, we just don't trust you, so we're going to make you verify. Again, these types of thoughts and these types of systems really help. Collaboration and information sharing, I'm going to talk about that one last. A lot of companies, I think this is one of the things you've done really well at AI Sweden, is whenever you come into AI Sweden and you're part of that network, you have to be willing to share information. And a lot of companies are very reticent to do so because that means dollars into their accounts. And they don't want to share that because it could be loss of shareholder trust. These are some of the dangers of using AI. So false positives and negatives. Perhaps the system is saying, hey, yeah, there's an attack over here. Hey, yeah, there's an attack over here. And the cyber teams are constantly having to flex, and they get exhausted because there's these false positives. The same can happen. Maybe there's new attacks that the criminals or the cyber criminals are coming up with, and the AI misses it. One of the big things in this is that there's a lot of complexity in it. So if you have an AI system running on your system, you need to have the expertise, but there's also a lot of power. You have to be able to power GPUs perhaps in a different way than you need to power CPUs. And there's a lot of resources that goes into using the AI. The expertise, frankly, is a lot of that it takes. And these are some of the cautions for using it. In the interest of time, I'm just going to keep rolling. We're almost done through this, and then we can have time for questions. I mentioned mosaics, more situational awareness for industrial control systems. That's the acronym. It was originally designed as a detection system, but it now has developed into a defense system. So it doesn't just detect the attack, it's learned how to defend against the attack, right? This is what I was talking about before. How do you use AI to do that? They were at Dakota State, the APL people were at Dakota State last week, and they're like, we want to partner with you. The person from APL told me, he says, I get students from 2 universities who are ready to go to work the day that they come. And we have a lot of DSU students at APL. He said it's Dakota State and Tulsa. I'm promoting Tulsa as well. And so he said, we want to bring mosaics to Dakota State. So we're working with South Dakota State University, who has these industrial control systems. We're going to work with them and bring mosaics into it. We're going to teach them the IT side of it. We're going to learn the OT side of it. And we're going to use mosaics as a way to do that. So this is just one example of one of the systems out there that you can use. Briefly, I just wanted to preview a few of the programs that we have at Dakota State. We're really looking at artificial intelligence in depth. We're looking at cyber operations. We're looking at cyber defense. Cyber operations, when you think about that, that's the red teaming. The blue teaming is the cyber defense, but you need red teamers and blue teamers together to have the best systems. I mentioned the quantum computing for cybersecurity certificate that we've just added that will start in the fall. So here's just a few of the systems. Finally, I wanted to show some of the DSU partners. Here, there's a lot of them. Johns Hopkins Labs on there, others. And then I just wanted to talk a minute about this partnership that we have with AI Sweden and how important it is. Mats at the beginning had mentioned that we have students here. We have 12 students from Dakota State here in Göteborg for a month working on these projects that are industry sponsored, industry driven. And just think about what that means for the industry and what that means for the students as they become graduates and go out into the workforce. I'm going to quote my good friend Mats, who says, if the hardest problems you have, you want to put it into the hands of students. The hardest problems, not me, not him, right? PhD from MIT. He says, I'm not the best person to give that to. Give it to students. Students don't have that institutionalized thinking. They are freer. They are more apt to come up with the best solutions. And I think the 23 students that we have working together on these industry projects are perfect examples of that. And we're so proud of what you're doing. So with that, this is what we've talked about. And we don't have much time. But we have no time.
We have till 9.
Oh, thank goodness. Sorry.
It's good. So we have 15 minutes for almost 4 questions.
So right after that comment that you made about leave it in the hand of the students because they don't have a lot of, they're not tied to the industry. Yeah. I am a bit tied from the industry, so my conversations are going to come from that a little bit. What tactics or what strategies do you implement to try to convince rural communities to adopt this, or how do you approach those systems? I worked heavily with rural water systems for a long time, and it seems like there's Lewis and Clark Regional Water System. You've probably heard of them. And there's kind of this system. So how do you go about approaching places that essentially are small communities down from 500 to 10,000? And I mean, it just seems like there's so much there to try to get them to adopt these things, and affordably as well. So
yeah, it's a really big problem. And in South Dakota, we have so much of this, right? I mentioned the fact that so many of the government workers or these industry workers are using their Yahoo accounts or their AOL accounts because that's what they've always used, completely vulnerable. From my experience, the best way to convince them is you have to show them examples. So you have to get an audience. How do you do that? One thing, at least in rural communities, and I think this is pretty universal, people tend to be pretty nice. It's also a huge vulnerability. We've taken students and just, knocked on the door and said, hey, here, we're here to work on your network. And they're like, sure, come on. And it didn't ask for a verification. And the students within like 10 minutes owned the system, again, at the request at leadership. We don't go and do this without their permission. We had an older woman, maybe gray hair. I think she was in her 70s. She actually did have gray hair. And she went in with some cupcakes and they let her into the president's office. She plugged a USB port into the president's computer and owned the system within minutes. People tend to be nice. So if you can get an audience with them, that's the first barrier. But a lot of times they're nice. So they're willing to give you that audience. You have to make a very 10-minute impactful presentation on why you think they're vulnerable. And what we have done, at least in South Dakota, is we really work with government systems to get grants so that that doesn't cost them anything. Once you can, if you can do even just a little bit without cost and show them then how to do it, we get a grant to go and explore, and then we got another grant to go help them secure it. That tended to be the way. In my experience, at least, and I think the same is very true here in Sweden, there is a lot of money out there if you know how to ask for it through different grants or different systems. And if you can get access to that funding and then show them how that you can improve their network, therefore improve their profits, a lot of them are willing to do that. I hope that at least gives you some ideas of ways to think about it.
Yeah, absolutely. Yeah.
Next question.
Thank you for the awesome presentation. It's very interesting. I was thinking a lot of this, you talk about these new smart systems. And of course, we need to make our systems more secure. But at the same time, when we increasingly connect them, this opens up a lot of new attack vectors, I feel like. And how is this taken into account?
Yeah, absolutely. It is. The number one thing to consider is from the moment the systems are developed and created, that cybersecurity is at the forefront of the thinking. It's not at the back end. In other words, we don't create the system and then sprinkle some cybersecurity on it. We think about cybersecurity from the very beginning. I think that's the difference there. You have to really consider a lot of these things that we talked about, whether it's multi-factor analysis or it's using biometrics, whatever those cybersecurity measures are. And this is where I think as the AI, which I mean, it's just exploded. I was at an AI conference in Stockholm for the last 2 days, and I don't even know. I don't know if there's any count on how many different AI companies there are doing different things. Thousands. There's so many. They're so creative, and a lot of them have turned into billion-dollar ventures already, because there's so much of a need for it. It seems like an oversimple answer, but just thinking about it from the very beginning and having these considerations, having the expertise, these programs that AI Sweden is promoting, promoting the awareness of it and how to use the AI to protect the system, but understanding how it also introduces those vulnerabilities and protecting from it. I think it's knowledge. There has to be a human in the loop to consider those things, but it is resource intensive and it costs money to do it. But when you think about the money saved, this is why it's hard. It's like insurance. Insurance, some people, you just cannot convince them to buy insurance. And then when something catastrophic happens, it's catastrophic. Whereas I have learned over my life, institutionalized thinking, that I would rather just buy the insurance, whatever it is. I'm going on a cruise. I'm going with a friend. She refuses to buy the insurance because she's like, I've never had a problem. Well, I've had friends who have had problems. I buy the insurance. This is kind of the same thing. It's hard to convince companies sometimes, but as they are doing smart grids, they're doing so deliberately, and the cybersecurity is built in. But it's insurance, but it's very expensive if you're wrong. It could be catastrophic, but not just to the company, to lives.
Right, I have a question here.
Hi, Dr. Bell. Thanks for your presentation. It was very insightful. So you talked a little bit about harnessing AI technologies and methodologies to improve cybersecurity. Do you have any specific examples of the reverse about malevolent actors harnessing AI to achieve their goals?
I did a lot of research, and to this point, I could not find any case studies of where that has happened. Ask me again in a year, and I probably will have some examples. And I looked and looked and looked. I really did look to see if I could find them. I could not find any. So ask me again in a year, because the more that bad people, bad actors are aware, and the more they learn and they're learning how to use the AI, the more I think that possibility is. But if we're smart about it, maybe we can prevent it. Ask me again in a year. We'll see.
So thank you for the presentation, Dr. Bob. But I'm thinking also about the smart grid is that we're going to get more operators of the grid since there are going to be more people involved in the grid. We're also going to need more trust with all of the users. And if they're going to need to do AI, they also need more data. So how are we going to get that data out, and how are we going to prevent that data from spreading? Because that's not what we want either.
Yeah. That was one of the vulnerabilities of the AI, is the amount of data. Like you said, it takes, for the AI to be useful, it takes massive amounts of data. There could be poisoning of that data. That data becomes vulnerable in so many different ways, and we have to really consider that. I just think it comes back to awareness and education and understanding what those vulnerabilities are. There's no magic answer to this, right? So you just have to really be thoughtful. And the more you are aware of those vulnerabilities, the more I believe that you can protect against them. Things like, okay, let's participate in this conversation, whether you're in a program or part of AI Sweden, if you're at a university, I think that awareness, and if the more we can talk to the OT experts, they tend to be very historically in legacy grids. OT people said, just don't bother me about that IT stuff. But we have to open that conversation and get that conversation going more. But within those smart grids, I think that improves, because as the smart grid is built, it's built with that awareness. I feel like I'm repeating myself, but I think it comes to education and awareness.
Right. We have also checked online if there are any questions that's been typed into the chat, and we haven't seen any. So for you guys online, if you have any questions, please type them in here before we end. So I see if there's any more questions in the room here. And we don't have any here. So then I'll ask Dr. Bell, where do you think that Dakota State is going to be in 3 years under your guidance with relationship to AI and cybersecurity? What's your next exciting things to do at the university?
So recently we held a forum within LinkedIn where we're talking about our programs, and we just got approval to offer our Masters of Artificial Intelligence. We are looking at now partnering our Artificial Intelligence Masters with a biomechanics degree to build those together. We're just started exploring that. Maybe I'm not supposed to say that. Sorry, DSU leadership, if I let the cat out of the bag. That's one. I think the quantum certificate starts in the fall. One of the things about being in a regental system, meaning that the state of South Dakota has a board of regents that oversees us, there's goodness in that, but there's also some bureaucracy in it. So we have to really go through this regental system to get approval. But in this forum on LinkedIn, I already had students saying, hey, when are you going to offer a PhD in AI? And I said, let's get a MS, the master degree going first, and then we'll see what the enrollment is. And if the enrollment is strong enough, I feel very confident, then we could justify going into a PhD. But I think one of the biggest things is we're partnering now with Johns Hopkins APL, the Applied Physics Lab, and with South Dakota State, which is very important because they do so much in OT. And I think that's a really exciting thing that we're going to start in the spring. So we haven't actually even started that program yet. And we're going to really work on combining the education on IT and OT. So those are a few things. We're growing fast. We're trying to maintain that and maintain the culture, because one of the things we have is a really, I think our students hopefully would agree with this. We have a really close, it's a small classroom concept. So there's a lot of faculty interaction with students, and we want to maintain that. We don't want to be a university of 50,000. That's not our goal. Our goal is to stay a small university and be very specialized. So we want to do that, just continue with what we have and just get better at what we're doing.
I don't know if we have time for another question, but my name is Lars and I'm running a Swedish-based IT or tech company, but we are situated in like 15 different countries. So I totally agree with the huge challenge between, the relationship between IT and OT. Mm-hmm. This is something we experience every day. Yeah. So do you have any good examples on how to integrate that on a governance level? Because this is something we really faces every day in both companies and organizations. I think you addressed that you should work on this on educational level, but also, running companies. So have you any good examples on how to kind of connect these two?
I don't feel like I have the best answer right now. My experience comes from defense, right? So I don't have as much industry experience, but I super appreciate the question because I feel like that's something that I will explore now more due to your question and really start talking to industry leaders more. I've started this conversation, but I have a lot more to go. So I don't have a super great answer for you, but I'm going to work on having a better answer. Ask me again, maybe not in a year. Ask me in like 3 or 4 months. I will have a much better answer for you. And thank you so much for that thought and that question.